Hello students, today we are going to discuss the product of vectors. Means when two vectors are multiplied with each other, so you are getting a product, and we are getting two kinds of products. One is called the scalar product and the second one is called a vector product. So the first one is the scalar product. We are starting from the scalar product. When two vectors are multiplied with each other and the result is a scalar product, scalar quantity, so such kind of product of two vectors is called a scalar product. You have two vectors, you are multiplying them with each other and the product is a scalar quantity. So such kind of product is called a scalar product of two vectors. And there are some examples. For example, work is example of scalar product. For example, work is a scalar quantity, and work can be obtained by multiplying force with the displacement. Force is a vector quantity, displacement is a vector quantity, and when you multiply both of them, the force and displacement, you are getting the work. Work is a scalar quantity. So first example is this one. Second example is the electric flux. Electric flux is a scalar quantity, and it is obtained by multiplying electric field intensity with the vector area. You are multiplying electric field intensity with the vector area and you are getting electric flux. Electric flux is a scalar quantity, while electric field intensity is a vector quantity and the vector area is also a vector quantity, and you are multiplying them with each other and you are getting electric flux. So electric flux is a scalar product of the two vectors, which are electric field intensity and vector area. The third example is power. Power is a scalar quantity and it is obtained by multiplying force, which is a vector quantity, with velocity, which is also a vector quantity. So force and velocity both are vector quantities, and you are multiplying with each other and you are getting the power, which is a scalar quantity. So it's also a scalar. Power is also a scalar product and it is obtained by multiplying two vectors, force and velocity, and the product of them is power, which is a scalar quantity. So this is called the scalar product. Again, when the product of two vectors results a scalar quantity, so this kind of product of the product of two vectors is called a scalar product, or it's also called dot product. So you can use a scalar product for it, or it's also called a dot product, because dot is used dot symbol is used in place of multiplication symbol. Yeah, as for multiplication we use dot, so that's also called a dot product. Okay, so now we have two vectors. Let's say vector A and vector B. We have two vectors. It's a vector A and another one is vector B, and the dot product of these two vectors will always be equal to the magnitude of vector A multiplied by the magnitude of the vector B multiplied by cos theta. Okay, so you got two vectors, vector A and vector B, and the product of these two vectors, formula for the product of these two vectors is equal to magnitude of vector A multiplied by magnitude of vector B multiplied by cos theta. And you can write this like this one: A dot B is equal to A. For the magnitude of vector, we can just only write A, and B, this is the same as this one. This one and this one is the same. This one is the same. Cos theta. Okay. Now the product of these two vectors, which is a scalar product, is depends upon the angle between them. If the angle for maximum, theta should be equal to 0 for maximum. Okay, for maximum scalar product, theta should be equal to 0. When the theta is equal to 0, then that will become A dot B is equal to A B cos 0, which will become a b cos 0 is equal to 1, you will get only ab. This is the maximum product of two vectors, okay? And for minimum, theta should be equal to theta should be equal to 90 degree, because cos 90 is equal to 0. So a dot b will become a b cos 90. So a b cos 90 multiplied by 0, you will get 0. So if two vectors which are multiplying with each other and they are perpendicular to each other, so the result will always be minimum, which is equal to 0. So in case of work, the work is equal to f d cos theta. So if the angle is equal to 0, you will get W is equal to f d. That will be the maximum value. For similarly, for electric flux, E delta A cos theta, if the theta is equal to 0, so you will get E delta A. And similarly for power, if V cos theta, if theta is equal to 0, you will get maximum power, which is equal to, which will be equal to FV. And if the angle in all of them is equal to 90 degree, means the force and displacement are perpendicular to each other, you will get 0 work. Similarly, if the electric field intensity is perpendicular to the vector area, you will get 0 electric flux. And similarly, if force and velocity are perpendicular to each other, so you will get 0 power. So for maximum scalar product, the angle should be equal to 0, so you will get the maximum vector scalar quantity or scalar product. And if the angle is equal to 90 degree, you will get the minimum value, which will be equal to 0. And if is the angle equal to 180 degree, you will get negative quantity, negative scalar quantity. For example, if force and displacement are at 180 degree to each other, so you will get minus FD, that will be a negative work. Similarly, you will get negative electric flux and you will get negative force. And here these cases are being given here. For example, if you are getting cos A dot B is equal to AB cos theta, if angle is 90 degree, you will get AB is equal to 0. Similarly, for work WD cos theta, if the theta is equal to 0, you will get maximum work. If the theta is equal to 90 degree, you will get 0 work. So these are the this is the scalar quantity, scalar product. In the next video class, we will be studying the laws obeyed by scalar or scalar product or dot product, the commutative law and the distributive law of dot product. We will discuss inshallah in the next video.